Okay, welcome to the part 2 of the logic coverage in module 12. So in this part, we're going to discuss in the more detail how can we apply the concept of logic coverage to the source code. So to sum up again, we have the concept of logic coverage, and we identify the test requirements for each of the criteria like predicate coverage, clause coverage, or combinatorial coverage, and active clause coverage. So if we apply this to the actual source code, there are more things to do than just applying these criteria. We need to make sure that the value that we chose follow such kind of criteria, and some of them might not be actually be able to reach the location inside the code. So we're gonna discuss the concept called reachability of the predicate as well. Okay, so let's get started. We discussed that we have decisions inside the program, and this decision contains predicate, which means the statement that are evaluated to either true or false. And most of the programs, the predicate have less than 4 clauses, and we can apply this kind of criteria like COC, ACC, and CC. But when the predicate has only 1 clause, everything will just sum up to be PC because you have only 1 clause, and everything will be the predicate coverage, right? But in the real world, you might have the clause, more than 1 clause inside the programs. So to apply this kind of logic coverage to the source code, it is quite difficult because we have some kind of problems that we cannot get to the locations that we want. And we have the controllability problem that might prevent you from getting the test cases to the location that you want. So we're gonna discuss what are reachability and how can we use it to analyze the software based on logic coverage criteria. Okay, so I will use this running example for the whole part here. So if you have the method called number of days, okay, the method number of days accepts 2 parameters, x and y. And these are the only input that we can manipulate to the parameter, to the method. And this is the method to return the amount of days depending on month and year, okay, which we need to take into account the leap year as well. So if it's a leap year, the February month will have 29 days, okay. But if it's not a leap year, then the February will have 28 days. So with this, we write the code as follow. So if month is less than 0 or month is over 12, then you throw illegal argument exception. And we say that the month must be in the range of 1 to 12. If M is 2, which is Feb, we're going to check for leap year. And if it's a leap year, so this is a leap year, we return 29. If it's not a leap year, then we return 28, all right? And the next one is when the case of the month less than July, if it's a even month before July, you have 31 days. But if it's an even month after July, then it will have 30 days, okay? No, sorry, it will have 31 days. Oh, sorry, I did it wrong. So I explained wrongly. So if this is if it's an odd month, okay, before July, then it is 31 days, like January, March, May, okay, and July as well. But if it's more than July, so those are August, October, and December, then the even month will have 31 days. Yeah, sorry. Okay. Anyway, it's a source code that compute this kind of number of days for you, and the rest of the months you will return 30. Okay. So if we analyze the predicates and the clauses in this program, you're gonna get the following predicates and clauses. P1 consists of two clauses, C1 and C2. P2 contains C3 only. P3 contains C4, C5, and C6. And P4 contains C7, P5 contains C8, and P6 contains C9. So if you want to apply the concept of predicate coverage to this program, okay, you get all the predicate and clauses, and in each clause, you derive the decisions here. So for clause 1, m less than equals 0, clause 2, m more than 12, so on and so on. So if you want to apply the predicate coverage, you rely only on the 6 predicates that we have, and you ensure that the predicate 1 have only have both true and false. Predicate 2 have both true and false. Predicate 3 has both true and false, so on and so on. When we apply the clause coverage, we are more focused on the clauses that we have. So you have 9 clauses, C1 to C9. Again, you have to ensure that both of them becomes both true and false. Okay, for example, this one is true, this one is false, so on and so on. And when you do combinatorial coverage, you check for all possible value of each predicate. So for predicate 1, you have 2 clauses, you have 2 to 12 of 2 combinations. So you have 4 combinations, which is this one. For clause 2, you have only one. For predicate 2, you have only one clause. So you have 2 possible combinations. Clause 3, you have 3. For predicate 3, you have 3 clauses. So you have 2 power 3, you get 8 combinations as shown here, so on and so on. So the combinatorial coverage, you get a lot of test cases, right? P1, P2, P3, P4, P5, and P6. But in this kind of source code, you might not be able to reach every single predicate just by giving any specific value. So there are the concept called reachability here. So let's analyze the reachability. So if I say R of P1, I want to say reachability of P1, which means how to reach the predicate P1. All right. So if you want to reach the predicate P1, it is the beginning of the method here. We don't actually need anything. So this one is always reach. So reachability of P1 is always true. The second one is the reachability of P2, right? If we want to reach this specific location, we need to make sure that this is false. Because if it's true, you already execute this throw statement. So the predicate P1 must be false, right? Which is not of P1. And that means you want the month to be more than 0, and you want the month to be less than equals 12, which is the negation of this predicate here. Okay, so to reach P2, you get not of P1. Next is to reach P3. P3 is under this if statement. So you will reach P3 when you got m equals 2 only. So that is when your reachability of P2 is true and P2 itself is also true. So that means the month must be less than 0 and less than or equal 12, and the month itself must be February only. So finally, we get the reachability of P3 as month equal 2. Next, reachability of P4. it is, we can see that it is outside of this if statement, but you will reach this one when P1 is false, when P2 is false. So if it reach P4, you must already reach P2. Just a moment. Yeah, you must already reach P2 first, and P2 is false. So this one means you must not get into P1 and you must not get into P2. So not of P1 and not of P2. So the month must be more than 0 and the month less than equal to 12, and the month must not be February, because if it's February, you get into this predicate and you don't reach this predicate, right? Again, for P5, we need to get into this predicate. So it is something different now. So you must reach P4 first, and P4 itself must be true. We follow the same restriction for the month. The M must not be equal to 12 because it's based on the reachability of P4 here. And finally, itself is M less than or equal 7. So this one must also be satisfied. And the last one is P6. P6 is when you reach P4, but you don't get into P4 and you skip here. So this is when you reach reachability of P4 and not of P4. So you have everything as before, and you flip the last bit to be more than 7. Okay, there is a lot going on in this slide, and I think you might need some time to digest it. So you can pause the video a bit, trying to see how we come up with this final set of reachability, and then you can continue the video. Okay, so for now, if we already know this kind of reachability, we can start deriving the test cases. So starting with the predicate coverage, we want to make the predicate becomes true and false. So for predicate P1, if we want it to be true, because P1 depends on C1 and C2, right? C1 says that when M is less than equal 0 or M more than 12, so we can pick one value to make that predicate becomes true. So I pick M equal 0, and then the predicate P1. Oh, sorry. So this predicate P1. Oh yes, yeah. The predicate P1 will become true because M is less than equal 0, and then we pick 0. And the other case, so this is a case where this is true, and this is a case where this is false. So if I want the predicate P1s to become false, I pick the value of M. That is the opposite of the value in the predicate. So I pick M equals 1, and 1 will make this one to become false. And it also make this one to becomes false. And then this predicate will also becomes false. Sorry. And next, if we move to the second predicate, P2, M equals false, M equals 2 or not. No, P2 depends on C3, right? So if I want it to be true, I pick month equals 2, and then everything will be true. And if I want it to be false, I pick the month, which is within this range, because I say that reachability of P2 must be the value of M more than 0 or N less than or equal to 12. So I can pick any value more than 0 and less than equal 12 and not equal to 2. So I pick the value 1. Okay. Next, we move to the predicate P3. The predicate P3 depends on C4, C5, C6. So this is the check for the leap year, right? And it depends on the value of Y now. So if you want the predicate to become true, At first, we need to get the month to be equal to 2, because if we want to reach P3, you want the month to be equals to 2. Okay, so we fix the value of m to be 2 in both cases. And then we look at the value that makes the predicate become true, which is a leap year. So this is a case where a leap year occurs. And this is a case of not leap year. Okay, and then you keep doing this for P4, depends on C7. C7 say that m must be less than equal to 7. To reach P4, you must have the month within this range, and the month is not equal to 2. So we pick the value that in the range first. Okay, so this value can be any value within this range and not equal to 2. Okay, so I pick the value of 3 for the first case. Okay, and then you get m less than equal to 7, so that you get true. And for the false, I pick the value that is more than 7, so I get false. And then you keep applying this to P5 and P6. All right. So if we move to the clause coverage, you kind of follow the same logic here. So each clause is shown here. And when you want to derive each clause to be true and false, you find the value of m and y to satisfy such specific clause. Okay, and in some of the cases, you can find the test input by just considering the reachability, and then you will know that there are only these cases occur. When you do COC, then you get more test cases to cover, and you might need to check, but some cases, is this infeasible to do? Like, for example, in this case where you need to have C1 and C2 to be true, which means you have to have m more than equal, m less than equal to 0 and m more than 12 at the same time. So this is infeasible. You cannot do that. And the other cases, it will force you to select something like C1 is true, C2 is false. Is this when m less than equal to 0? The other cases is false true when m is not less than equal to 0, but it must be more than 12. Okay, and the last case is when it falls into that range and you get to pick any number of m. And then you continue doing that. So this is when the case that it is February or not. And this is the case where it is a leap year or not. And you can also have some infeasible cases that the clauses are conflicting by itself and you cannot find any test cases for that value. So keep going on, and then you can derive all the test case value here. Some of the test cases that you have are duplicate, so you can share them. Like this one, m equals 3. This one, m equals 8 work. This one, m equals 1. So finally, actually, you can save some of the value that you choose as the final test cases. The last one is when we apply correlated active clause coverage. So you do this per predicate. Okay, so you start with, this is for predicate P1. This is for predicate P2. So for each predicate, you make each clause active at a time. So you have the case where clause C1 is active, and you have the cases where clause P2 is active, and then you derive that situation, okay? And then you derive the set of possible tests for M and Y. And you keep doing this for P2. You do this for P3, which is such a big table. This is P3. Okay. And then you find a set of possible tests, and then you go for P4, P5, and P6. And then you also derive the possible tests. Okay, and if you go to the test input, you get the actual value for M and the actual value for Y. Okay. In this case, you need to choose the value of M to be equals to February, and you find the value of year to be leap year and not leap year. Okay, and you can share some of the test cases that you have, so on and so on. Okay, so that's all for applying the logic criteria, the logic coverage criteria when you have the source code. There's a lot of concepts, and I think it needs a lot of exercises to fully understand this concept. So to summarize, we discussed logic coverage, which mainly based on the predicate, which is the decision statement inside the source code. And the predicate have a few clauses inside, and we exercise these kind of predicates and clauses to come up with the test cases based on the logical operations and the verbal, the value that you get from the predicate, either they are true or false. And by having the logic coverage criteria of predicate coverage, clause coverage, combinatorial coverage, and correlated active clause coverage, we can dive deeper into finding the test cases that fully exercise and infect the fault to be creating the software to have incorrect internal states. And that's all for the logic coverage. And that's all for this module. See you in the next module.